we've been talking about AI fine-tuning. Uh, the reason why we have been focusing on these two a lot is because LLMs are trained on some limited data set. So because LLMs are trained on some limited data, like the information that they have exposure to is also going to be limited only. So, and if you have a specific use case, okay, and you have some organization specific data, if you have some organization specific data, then how do you really make if you want to use any generic LLM off the shelf, then this LLM might not have exposure to this organizational data. Then it won't have any knowledge, right? It's like you have an engineer, civil engineer, who has been trained on civil engineering, and then you are asking him about computer science. He has never looked at that type of information. Okay. So he cannot really answer questions related to computer science. Similarly, like an LLM which is trained on some generic data set or from information which is available over internet, it won't have access to the specific information that you might have in your in an organization or in your data record. How do you then, in that case, okay, in that type of situation, how do you use these LLMs? So two techniques are, one is use RAG, okay, which is sort of information augmentation. Okay. So RAG stands for retrieval augmented generation. So here you are augmenting the information in the prompt. Okay, into the prompt that you're passing to LLM. Okay. So that is one technique. In RAG, you pass the information within the prompt itself. Okay. Second way is you, whatever model that you have, okay, you do the fine tuning. So fine tuning is like, okay, you have a civil engineer. You only knew about civil engineering, but then you're like, okay, take some computer science courses. You teach him data structures and algorithms, okay, and you teach him some, say, operating system, okay, one or two courses. Now he would have that specific information, okay. Uh, so that is how fine tuning works, okay. You train this model, you fine tune it little bit more, so that now this LLM has that information also, okay. Now among these RAG and fine tuning, which is the technique that you would think, okay, like would is more like sort of more compute intensive? Which one would require more compute in terms of RAG and fine tuning? Right, exactly, correct. Because you have to train this, okay, update its parameters, okay. Whereas, so that's why like people start with RAG. Because this is just information augmentation within the prompt. Prompt anyways we pass to LLM. Prompt is an instruction to LLM. That we anyways pass. And along with that, we also pass some information that is from your organizational data. Okay. Yeah. Is that kind of concern where, for example, any place right. Yeah. Where, like in terms of compute, where am I pointing? Training or inference? That's your question, right? So inference is when there is training is like when you train the model. Okay. So in fine tuning, it is during the training. Okay, that your compute will go up. In RAG, during inference, your compute goes up, but very little, like 0.01% of what you will really spend if you really do fine tuning. Okay. I'll just give sort of an idea. Okay, like what would fine tuning a 70 billion parameter model mean? 70 billion parameter model requires two A100 GPUs. One A100 GPU has 80 GB RAM, so it requires 160 GB RAM to just store the model. Then you have to fine tune it to more memory, because when you are updating its parameters, you need to store weights that you're updating. So it means more than two A100s. Okay, you may require like 3 to 4 A100s depending on how much big your fine-tuning data is. Okay, or how many parameters you are updating of that model. So fine-tuning is always going to be very expensive, but it is a one-time exercise. Okay. But with RAG, okay, it's like you don't train the model. No. It's just that you say that, okay, you are a civil engineer, now here I'm giving you a book, okay. Now when I'm asking you questions, you can refer the book and give me answers by reading that. So that is what RAG is about.
So in a RAG, sorry for you. So, so in the RAG, you have to, like, let's say you have some PDF documents.
Yeah.
You have to call some API, right? Like, to kind of convert it into a vector or
Yeah,
something.
yeah, yeah, exactly. So there are database. Yeah, these are all good questions. So I think maybe you heard my previous lecture or
Yeah.
whatever. So that those things I covered. So for RAG, you are going to store this information, right? So the place where you store this information is known as vector DB or vector database. Now why do we call vector? Because we convert the information into vectors or mathematical representation. So you would always require a vector DB. Okay. So it's like carrying a book. Okay, always. Where in case of fine tuning, it's all in your brain. You learned it. Okay. So you don't have to carry any other book. Okay. So you need vector database in case of RAG. Uh, and generally so one more thing. Okay. Now is it uh, in the, so I've said that we are going to pass the information in the prompt. So should I pass all the information, the entire book? How should I go about it? Like whatever information is there in the book, should we pass all the information in the book? How should we go about it?
Or you get some words to match or index or something.
Right, right. Yeah, so you're thinking in the right direction. So what we do is, which is something I covered in the last class, we do in case of RAG, we do similarity search. Similarity between the question that you're asking and the information which is there in the vector database. Okay. So you compare, okay. This is also converted into a vector. Okay. And this is a store of vectors, V1, V2, Vn. So you compare this query vector as a QV with all these vectors. And now suppose you get that similar vectors are V2, V3, and V4, V5, V6. Okay. You can get any number of similarity vectors, right? You can rank order in terms of which is similar, which which is more similar. Okay. So suppose you get all these are similar, and if you rank order them, then we find these four are the vectors which match the most. Okay. So if you are saying top k is equal to 4, then you are going to pick these four vectors. You're going to see top k in the code. So that's what I'm saying. Like if top k is 5, then I can put V6 also. So it's like that. Okay. So it all depends on how much is your top k. Okay. So this part is clear. What are we doing in terms of RAG, right? So now we are really going to look at a vector database and like all the similarity search that we do. You said like we can do some keyword based similarity. Okay, so we are going to do some hybrid search. Okay, so similarity and in the code that I'm going to show, we are going to do vector similarity plus keyword similarity. Okay, so generally vector similarity does not give the best results. Okay, you need keywords. Okay, for information which is sparse. For example, if you are asking the name of the person, okay, who is Amitabh Bachchan? Okay, then that name may appear few times, okay, and most of the times they may be using some pronouns. So then how do you search for such type of rare or sparse information? So that's why keyword similarity works very well. There is a paper also that I shared earlier. I can share again. Okay, it is known as keyword augmented retrieval. You can check that. It's on archive, free to read for anyone. Framework is known as keyword augmented retrieval. Yeah. The paper is something like speaker. You can look at that paper. So can you little bit explain again? What part? Like when you have so we have RAG where we can
along with LLM, we
along with the prompt.
along with the prompt.
We pass the information. Okay, we are going to see that. Okay.
So LLM is basically our large language model like ChatGPT, OpenAI, and RAG is when we give prompt. Along with that, we upload a document or
Yeah, we are going to see that.
okay, and then we can do fine tuning or we can do
RAG. You can use either technique
or improve LLM.
for giving the LLM information. Your the additional information.
Yeah, additional context.
Additional context.
We can give via RAG or we can do via fine tuning. So now for RAG, you are saying there are two techniques: similarity, query, and info vector.
No, technique. It will become clear. We'll see it in the code.
What is this similarity and query and info vector?
So you will ask a question, right? You will have to compare that question, okay, with the information that you have already stored, right? So that is what I'm comparing. Okay, and there are two techniques: vector similarity and keyword similarity. Okay.
So can you tell? So like it's so the encoding for the query and the encoding for what the document.
It has to be the same embeddings model.
So same embeddings model there, but it's not the same as the LLM. Like one way you probably get an embedding is if you just casting, um, each of the documents, LLM. You get output, you get per token, you have after attention.
See, LLM won't be able to encode. Okay, LLMs are decoder based.
But you could get just like the token, you have some numeric embedding for each of the tokens at the end of the transformer, right?
Yeah.
So you could just take the last tokens.
So see, LLMs are decoder based. Okay, so they will only predict tokens. It will never give you an encoding. It will only give you a word. It will never give you a vector.
Internally, there's a.
Yeah, then it is like you have to. Yeah, you can pull it out. Okay, so encoder is nothing but doing the same job for you.
Okay.
Okay, because an encoder.
But they're trained for different.
See, decoder has one more thing. Okay, specifically answering your question, decoder has got cross attention. Okay, whereas encoder has only self attention. Self attention is meant for language understanding. Cross attention is meant for matching the information between the input and the output. So suppose you are doing translation. Now when you want to translate say English to say Hindi, then cross attention is going to cross the Hindi and English words together.
But you don't have to use like.
So you don't need for encoding don't need cross attention. Okay, so that's why you don't need decoder. Okay, you need use just the encoder part.
But even like ChatGPT or like GPT models, do those use cross attention? They just use.
They are decoder. Okay, they are all the GPT models are just decoder based architecture. Okay, only decoder. No, they have an embeddings.
Embedding, and then it goes through a bunch of.
But they don't have an encoder. They would encode the information, but that model as such, okay, GPT-4 or any of the models, which really generates the response, does not have an encoder. It is just decoder based architecture.
What do you mean it doesn't?
So
maybe the language I'm thinking.
So I'll have to get into the encoder decoder architecture to really give you that answer, but we are not going in that direction today.
So, I mean, I'm just trying to read off what he was saying. I think what you are saying is like with the encoding means like let's say we gave a query and like as a civil engineer example we have a couple of books or something. We basically encode it.
We convert it into vectors.
We convert it into vectors.
Right.
And we basically say the likely match between the query that was submitted
and the information which is stored in the vector database.
Stored in the vector. So let's send the query and the vector to the LLM.
No, we will send so first part is retrieval. We compare the query with all the vectors in the vector database.
And then pick the ones that are.
Exactly. So that's what I said, that when we picked, okay, suppose these vectors started appearing similar, okay. And if you say rank order their similarity, V2 is more similar to the query, then V3, then V4, then V5.
Correct. And then then the next step is you feed it into the LLM.
Then we will feed these into the LLM.
Into the LLM.
With the query.
Correct. And then the LLM knows.
Now LLM has additional information,
yes,
which was not there earlier. Okay, so now it can answer better. So that is what is RAG. This part is clear, right?
Yeah, one quick follow-up question. Sorry, I was using encoder. So you're just saying it only uses past token, not future token for GPT ones, but
Yeah.
whether we want to embed a document, we want to use all the tokens.
Yeah.
Mention needs to go.
Yeah, all the way, right. No, not just like, yeah, right. So masking, the way masking happens, okay, is different for both. Okay. So RAG, I think the approach is clear, right? That we get these additional pieces of information, these vectors. And then this query, these vectors, I need to erase it, okay. I can write here. So now you have your query plus vectors. Okay, say V2, V3, V4, V5. Say top case 4, so 4. Your query vector and whatever is the instruction, other instruction that is given. Okay, that instruction may be given this query and this context now respond. Okay, that can be your overall prompt. Okay, that given this query and this vector, you are giving an instruction that now generate a response. So this is the prompt that is going into the LLM. Okay, now let's look at the code. Okay. So try to okay, I'll share my screen. Actually, I put this code in a Colab notebook. I made some more changes to the code, so which I did not get time to upload there. So this is the repo, okay. My screen is visible, right?
Screen is not.
Screen is not visible. I have to share it again.
Yes, Prabhu, it is visible. It was visible earlier.
Is it visible now?
Yeah, at least I can see.
Yeah. Teams always take twice the effort. So okay, first of all, I will just show you an interface. Okay. Okay, so which I built, where what you can do is, so this one, okay, this one is actually about what I have fed is a Bhagavad Gita. I have fed Bhagavad Gita as a book to this model. I will add you. Admit it. Okay, so I have fed Bhagavad Gita. Okay, PDF file to this. Now I'm asking who is Prashant. Of course, there's nobody named Prashant. Okay, in Bhagavad Gita, at least to my knowledge, I don't know any Prashant in Bhagavad Gita. So it's the conversation is happening between Lord Krishna and Arjun, right? So when I'm saying my screen is visible, right? Yeah. So when I'm asking who is Prashant, it says like I'm unable to determine who Prashant is, right? And right now I've hosted it locally. Okay. Uh, I'm going to now go to the actual code which is behind this. Okay.
Did you already share a link to?
Yeah, in the meetings chat. Yeah, it's all recorded.
Does it connect to?
Yeah, they need some connector, okay. Because yeah.
So Prabhuji, can you send again? Because if I joined later, I don't see the message.
Just search on GitHub, Amaze 18, and then Bhagwan Vachan. Okay. AMA, so this is the handle, okay. This handle. AMA 18. Then there is one public repo, Bhagwan Vachan, okay. Just open that. There's a notebook, okay, that I uploaded yesterday. Okay. So let's go and take a look at the code now. So first I installed all the dependencies here, okay. Just take a look here, like I have installed the dependencies. These packages have to be installed, okay, because Colab as an environment has got nothing. Okay. So this is something I was thinking that one of you will pick up as a project, but I completed it yesterday. So first part is code block is install dependencies. That's what we are seeing here right now. Okay, I installed all the dependencies, right? So you have to do pip install. Okay. Then comes this code, okay, which is like the main crux of it. Okay, I will explain this. Okay. So
That's like right now.
so now what we are going to do is, okay, uh, here we are going to import those libraries. Okay, we install them. Now we are importing those libraries. Okay, this from business is all about importing those libraries. Okay, so you can ignore that. Then there is one place where I am putting the Google API key. You need to put your own key. Okay. Then comes the embeddings model. This is the model which is going to convert your what? What will it do? What will the embeddings model do?
Convert into vectors, your information, right?
Text into vectors. Okay. Embeddings model will convert the text into vectors. Okay. So what happened? My screen share stopped, is it?
She wants somebody to
That's okay. That's not okay.
Is it visible again? Okay. So you need to, first thing is we convert this text into vector. So that embeddings model I have specified. Now, Keshav, you are asking like which model, okay. So I'm using a model which is compatible with Gemini LLMs. Okay, so the name of that model is embeddings dash 001. Okay, and you need your API key. I have sort of removed my API key here. Okay, but you need to put your API key here. Okay, you can create your GCP account. Okay, and they give you $300 free credit.
It's very dark.
What did you say that embedding?
Can you see? Was my
We can see the whiteboard, Prabhu.
Please don't add anyone. Okay, it is. I don't know why it breaks the share.
Now we
Is
can
it
see.
visible now?
Yes.
It's again dark. What's happening? Yeah, Teams is very bad. It has hung now.
Yeah, I can see. Yeah, you can see your screen.
Okay, can you see the code notebook?
Yes. Yeah.
The Colab notebook? Very bad.
We need my WebEx. I can share.
No, Mataji, it will stop the recording. You have to remain on this bridge only. Let me shut down some of the apps in my
Advancing future.
We are still on. Can you just keep yourself out of backslide?
No, I'm just switching, restarting my Teams. Okay, is my browser visible now?
Yes. Yeah.
No, it's working. Yeah.
Yes.
This is a repo. Okay, this is a repo. Okay, sure.
Yeah.
You got it. Then this is the notebook. Okay, we are back on the notebook. Great. Just restarting solving. Just like all Microsoft things. So okay. Uh, so this is a Maddings model that I'm using. It is yeah, there like it's like some differences there. Okay. The latest version I will upload after the class. Now, if you look at this part of code, this is where we are creating the vector database. Okay. This is where we are creating the vector database. So we are adding document. Okay, like okay, and yeah. Path is also there. Everything you'll see later. Like uh, down somewhere here I have put. Yeah. See here. Here I have defined the path. You see, documents equal to. Okay. Now if you look at Colab here, here I have this folder data, and in that I have put Bhagavad Gita.
That's the Colab folder.
Yeah. So this is sample underscore data is the default folder. Okay, for Colab. And then with that I created a folder data, and in that my any document which is there in that folder means it will become part of your document set. Okay. So
So each PDF gets a different vector. Only one PDF. There's only
right now one PDF. No, one PDF will what it does. Okay, good question. So you have your PDF or whatever documents that you have. Okay, one or two whatever documents that you have. You take out all the text out of it. Okay, and then you break all that text into smaller chunks. Okay. So suppose this has got, say you have got 5 files here, and those 5 files have got say 500 pages. Okay. Now what would happen is you are going to get all the text from these 500 pages, break it into smaller chunks. Okay. Now these chunks would also have some size. Okay. So like like you will see that there is work okay on like what is the optimal chunk size. Okay, chunk size optimization करके there is on paper. Okay. So generally people use in the order 1024, 2048, okay, something like this. In this order people use. Okay, chunk size. Okay. So you'll break all this into hundreds of chunks. Okay. And then each chunk is converted into vector. Okay. So you do chunk creation, and those chunks are created into vectors, and then those vectors are stored into your vector DB. Okay. The step that we are seeing here is we read all the information, okay, into that documents variable, and then we are converting that into nodes, okay, or chunks you can say. Okay. Then actually this part I could have kept down. Okay, it's not required here. Okay, but it's fine wherever it is. Okay. Then what we are doing is then we are creating, if you look at vector underscore index equal to, okay, or keyword underscore index, right? So now we are converting it into vectors and storing it, okay, into vector store and keyword table. Okay, this line of code. Okay. Now don't worry about the custom retriever. Okay, like only if you know Python programming very well, you need to worry about it. Otherwise, skip it.
so your vector store index, vector store, that is a persistent storage? Or is it-
Yeah, very good question. So again, like there, like you can define it as persist, okay, or not. Okay, like so there is one variable you can say persist equal to true or false. Good question.
What does that mean?
So persist is like it will going to store, retain it in the memory.
It's everything.
Yeah. Otherwise, you'll have to every time create. Like means suppose you restart your notebook and everything will be gone. If you'll say persist, okay, it is going to remain there. I'll share my screen again.
Like on disk or
Yeah, in RAM, yeah. Is my screen visible?
you can't like construct that to persist.
See, then what you can do is like you can actually have a vector database. For example, you can use uh, uh, Pinecone, okay, or you can use Fias, okay, which is from Meta. So there are different vector databases. So it will store as a particular file, okay, like with an extension. It will store it maybe in your cloud storage or in your own system. It depends. Is my collab visible? No, not. Big problem.
It's a live service, then you don't want it to recompute those vectors again. Like, say, just similar relation and all.
Haribol Prabhu, is that only me or someone? I can't hear you. Hare Krishna Prabhu. Hare Krishna Prabhuji, I can't hear. I think you're on mute.
Oh, okay, okay,
Oh, okay,
sorry.
okay, sorry. Okay, thank you. We lost a lot of things what you have taught so far.
Oh, I was not aware. Uh, so what I was saying is we have this vector similarity and keyword similarity. Both the things are going on, and that is what this custom retriever is actually doing for us. Okay, and use then we get. So if you look at this custom retriever, okay, it has got both vector retriever and keyword retriever. Okay, okay, and then what we are doing is, um, so one is your retriever thing. Okay, so you have your vectors. So you have stored all the text in the form of vectors. Okay, in vector database, and you have converted the extracted the keywords out of the chunks. That also you have stored in the form of a keyword table. Okay, now storage part is done. Okay. Yeah, so like there are frameworks, okay, just to extract keywords, okay. So one framework will just create tokens out of it, okay, and then identify which are the words which are really important, okay, like nouns, okay. It will sort of do away with sort of pronouns and all the stop words like prepositions. So it will throw away all those things. Okay. So this custom retriever is now a sum token. So yeah, we have this information now. If we really want to use this information, we need a retriever, information retriever. That is what your custom retriever is doing. Now, if you'll pass a query, what this custom retriever will do is it will find out the chunks of information which are similar in meaning based on the vector similarity, or chunks of text which have keywords which are similar, okay, between query and that chunk. For example, like if we ask about, okay, who is Lord Krishna? Now, whatever chunks would have Lord Krishna mentioned, it will pick all those chunks based on keyword, right? But it may be so that not every chunk is important, okay? Because not every chunk may be defining things about Lord Krishna. Okay, one chunk may be saying, okay, Lord Krishna said this to Arjun. No, it has no information. So that's why you need vector similarity also.
So this keyword similarity, like you could define words like counts of keywords to be percent similar.
Yeah. Like the
Is
other.
that what's happening, or is it just um, like any overlap, any keywords pulling out? Like is there some
Yeah, so keyword similarity is only looking at keywords. Okay, it does not know the meaning. Does not know the semantics. It is just looking at those chunks which have keywords in common. Based on some thresholds are there. Like so the query, yeah. So suppose the query has got say three keywords. Your question has got three keywords, and different chunks have got different number of keywords. So it will match. Okay, like these three keywords are having an overlap with how many chunks. Now, if it finds an 100% overlap, all those three keywords are found in a chunk. That chunk will be picked up.
so it ranks those? Like
Ranking will come later. Okay, I did not come to ranking. Okay, don't go there. I'm just saying you're retrieving. So retrieval is happening using this custom retriever. Okay. Now comes okay.
custom retriever doesn't look at the vector.
No, it has both the things. It has vector retriever as well as keyword retriever. It is a hybrid of both. Okay.
It has to
Vector retriever will look at semantic similarity.
also rank.
It will, I have not defined ranking. I am just saying that I got lot of chunks, okay, which are similar. I'm not talking about similarity yet. Okay. So with vector retriever and with keyword retriever, I will match some chunks. Okay. I did not define the threshold so far.
So
Okay.
right now that you're retrieving two separate.
Two sets of chunks.
Might have some overlap. But
Could be. Okay. Two sets of chunks. Okay. Now you can have an and or an or condition between them. That's what is defined in that custom retriever class. You can say and or you can have just or. Okay.
But vector doesn't give you a set of chunks. Vector gives you a list of
Vector is also coming from chunks only, right? We converted vector.
list of similarities from all the chunks. You have to cut a threshold.
Yeah, I did not come there. So, okay, I'll go there. Okay. Now, if you look at vector retriever, the way I have defined, okay, it has got similarity top k is equal to 5. Okay. So, it will accordingly just pick these five chunks which are most similar. This number can be anything. Okay. Where did I define keyword underscore index? Yeah, here is where I defined. Okay. Okay. So all the keywords from different chunks. This keyword implementation is little encapsulated, so I don't want to get into its detail today. Okay. We are using a library, all that, so it will just retrieve. So now, based on this custom retriever, we'll get like top 5 vectors which are similar to question based on semantic similarity, and chunks which have got keywords which match your query. Okay. So now you have the relevant information, okay, which you want to feed into the prompt. So that is what this response synthesizer is doing. Okay. Uh, it will get a object of uh, yeah. It will get an object of response class, okay, which will have all those things, LLM related things. Okay. Response synthesizer class you defined above. So it has got all those things related to, okay, what is the LLM? Okay. You can look at it here.
So maybe I'm missing a small piece. So
Yeah.
the the vectors, like let's forget the chunks. I mean the keywords for a while.
Hmm.
Just the vectors, you would rank the top 5 and send it to the LLM, right, with the query.
Yeah.
So the vectors are already kind of encoded. So
So we don't send a vector. We send the corresponding chunks.
oh, okay.
So
So
vectors and
to do some work to
no, you don't have to. That vector. So vector database would have what? It is a table, okay, which has got chunks. Okay, this is your text. Okay, and this is your vector. Okay, so it will give you the corresponding chunk.
okay.
So this chunk is now going to go into the prompt, which is being passed into the language model.
Okay. So in that case, it's seamless. Like the keywords also operate the same way.
Yeah. Exactly.
So Prabhu,
So there what do you do? Like there you will be like select a statement where this equal to this. So there you don't have vectors, right? You have actual words. So your SQL database are similar to your keyword thing. There, do you have vectors? Do you convert it into vectors? Any text? No, right? So that is the main difference.
so Prabhuji, sorry, I missed maybe in between, but
Hmm.
you might have mentioned, but I missed it. It might be repetition. So you said that this vector index retriever and all those things, and we make the chunks, and we using this library to get where this data
So
actually stored.
this is stored in vector database. All these vectors are stored in vector database.
Vector database, but where is it, in the client side or what?
No, vector
Where?
database will be on your where the place where you're running your code. It will be on your own system.
Yeah. So on our machine, I mean client side, not
Exactly, on your own machine.
on our machine. Okay.
Yeah.
So we don't need to create it. It creates by automatically in
Yeah,
memory
I
or something.
showed the code for that. So it will create a vector database and store it in your system.
Okay.
Okay.
So the embedding happens before the chunks are created or after the chunks?
So I told na, like chunks are created into vectors. And then vectors are stored in vector database.
When embedding happens.
So I showed here, like text or chunk is getting converted into vectors using embeddings model.
Before the chunks are stored,
First you need the chunk, right? Then only you can get vectors out of it.
okay, so after this process.
So first column will be your text chunks column, okay, in your vector database. Second column will be vectors.
The chunks are stored and then embedding model will run on.
Exactly.
Create the vector
and then they will store. Okay. Okay. I'm making it very simple that it is looking like a table. Okay. It is not like that. Okay. This vector retriever works on clustering algorithm, KNN and K-means. It's a different one. Let's not go there. Okay. So now you have this custom query engine. Okay. So it is using two things. Okay. One is your custom retriever, which you defined, and one is response synthesizer. Now this response synthesizer is having all the information related to the language model that you are using. So two objects I'm passing. Okay, one is your retriever object and another is your related to your LLM. Okay, and then we are expecting it that it is now going to give us a response. Lot of encapsulation is there. Okay, like in this code, we are using object-oriented programming here. Uh, so now when I ask, okay, like things like what is the secret Krishna is telling to Arjun? Okay, now this is actually only related to Bhagavad Gita, the book that I uploaded here. It is a PDF of Bhagavad Gita. It's uploaded here. Okay, so it will only respond to questions related to that. Otherwise, you will ask anything else. For example, when I showed here, like who's Prashant, I said, no, I'm not able to determine it. Okay, so
That based on the base LLM saying like
no, it is based on the no content. It was not able to find any vectors, right? If it had something similar, then it could have given an answer, but it could not.
so there's no chunks that are returned.
Yeah, it will say I don't know. So, well, I wanted to actually explain the interface part of it as well. How did I build this UI? But probably that could be a topic of another class. I use Streamlit here. Okay. And yeah, I mean, I would suggest like that if once I share this code, I think all of you should try building a Streamlit app so that you'll get some idea. Okay, like how does a RAG application really work? People keep talking about agents, right? This is Agent 101. This is where all starts. Okay. Now, if you have an interface like this, you have like your retriever and your LLM all set up. Okay. Retriever is also giving a plug to a database, right? So it what does Agent do? It integrates different services. So we have integrated one service already today, which is your database. Okay. Now, if it is like you want to take some actions, action also we are taking. We're retrieving the relevant information from that database, right? But if you want to perform some other actions, like say you want to say book a ticket and all those things, then you need to get their API and all that authentication done. So that we are not going to cover. But this is Agent 101 where we are interacting with a LLM is interacting with some other service. And it is able to fetch information and based on that it is able to give a response.
Where is it happening as part of Streamlit or
No, so that response synthesizer class is having all that.
is hosted as a service?
No, that is like a package itself. Okay, like means it has got everything in there. Okay, that so the prompt there looks something like uh, so what is happening is see you have your LLM and you have your retriever. Okay, so retriever is and you have your prompt. Okay, so retriever is getting you the information, injecting it into the prompt. Okay, and then this prompt is going into the LLM. So far, and this prompt is having what your query plus text chunks. Okay. And where are these chunks coming from? Vector database. Right. So far, what was happening was we were just passing prompt with the query. Now we are passing chunks also, which are coming from the vector database. Okay. So this is a form of an agent only where you are interacting with another service, which is your database.
So somewhere in the code, you must be to a similarity matching. Somewhere in the code, you must be converting the query itself into a vector. Right?
Yeah. So all that is little encapsulated. That is happening.
So
Yeah.
that's in your class.
So the thing is, like earlier when Llama Index package really started 2 years back, okay, or LangChain, there the way they have written the code was very sort of like low level, I would say. You could really understand that this is where the prompt is going, this is where a query is getting converted into vector. Now they have done so much encapsulation, it has become very unreadable. Okay, it becomes simple to use, but it becomes very unreadable to understand what is really happening.
So they're kind of doing it
They're
under the
doing,
scenes.
they're doing. The response synthesizer is doing that for you. It is converting that query into a vector. Okay. Sorry, no, this vector index retriever. Okay. See, when we are doing this custom retriever, right? Okay. It gives us a object custom retriever. Okay. And that along with the LLM, okay, response synthesizer, they get encapsulated into a query engine, and you are passing to that query engine the query here. So then the query engine takes care of converting the query into a vector and then taking this retriever, okay, taking this retriever and finding out all this information from the database. Okay. I have a simpler version of code also, but then it uses sort of legacy code. Okay. So I'll stop the session here. Okay. Is there any questions you can take now? Okay. Yeah, I'll share this code. And
Prabhu,
yeah,
uh,
Prabhu.
yeah, it would be great. I mean, yeah, you explained, but it's very hard to basically follow sometimes. So if you have time, maybe later, would you please comment this code more like steps so that we know what
Yeah,
part
yeah,
is.
I'll try to do.
Add more comments in the edge
See,
section.
you can put this code in ChatGPT and it will comment for you. I will do the same. You can do it on your own.
No, no, comment means you can explain, right? Okay, what is this vector retriever actually? Here we are doing vector retriever and keyword retriever, this two retriever
So
defining.
probably a lot actually happened on whiteboard today. Okay. So that's
Okay.
why you're not able to relate probably.
Mm-hmm.
Okay.
It is recorded, so you can go back.
Yeah, you can go to, yeah, I think the whiteboard got recorded. You can look at that recording too. Sorry? Yeah, I think it is stopped now, but
It got disturbed, so you
yeah.
stopped it.
Yeah.
Prabhuji, where did you share this code, Prabhuji?
Oh, it's here, Prabhuji. It's here. I'll share the latest code with all of you, but this is
Can you
where
put
the
that
file
link
is.
in the WhatsApp, Prabhuji?
Yeah, Prabhuji, I will do that.
Thank you.
This code while ago.
Okay, okay.
So my code will not get the.
No, it won't disturb anything. It won't disturb. Prabhuji, I am putting here it on the chat also, team chat.
Thank you, Prabhuji.
Yeah, I have been using same repo, Prabhuji, all the
Oh,
while.
okay, then we can get it from there, Prabhuji. Okay. Bhagavan Vachani, okay.
Do you know, I found this code.
Yeah.
Would it, my forked repo, would it have?
No, it won't.
Latest changes? No.
No, I pushed the code yesterday evening, so that's what we have.
I have to fork it again.
I think so.
So I mean, you are using the Colab, right? Is it necessary to use Colab or you can
Use
use
anything.
Visual Studio and
You can use anything. I just generally use Colab because generally like installing dependencies on all that is easier in Colab. Yeah, VS Code if you'll use in your system, okay, it will say this version conflict, that conflict. It will mess your head up. Okay, and like I have like times, okay, when 15 minutes just went into that, okay. In Colab, everything happens in one shot. Okay, it's like bare metal. So you install, it will create a new environment and you don't run into those dependencies issues. Yeah.
Suggest some projects.
So one project I suggested earlier also, like which I did already. Okay. So I will not share the Streamlit code. Okay. Ye code I will share. Try to create a Streamlit application around it. Put Bhagavatam in that. Okay.
Yeah, PDF.
Yeah, we have. Everything is online. Go to, I think, Veda. Everything is there.
But that is the web page, right?
No, there are PDFs also. Yesterday I was trying to do, but it is such a large, voluminous thing. I was not able to really upload anything. It was taking a lot of time to create vectors. But there is, just check, okay. There is entire Bhagavatam, okay. So that can be a project. I've been like, this is the same project I told, I think, many of you. Okay. And I covered RAG and similar code earlier also, but today I covered like everything, like, okay, end to end. Okay. So,
that might be interesting because you can see in action that it's picking it up from Canto 4 instead of Canto 8 because it's matching the right chunk.
yeah, yeah. Then see, like, then once you'll start doing, you will run into limitations with just using vector and keyword retriever. Okay. Then you'll say, oh no, we need something more. Okay. So there are other frameworks also of retrieval. Okay. Okay. So you can then use those frameworks. Okay. Dense retrieval. Okay. There are dense retrieval techniques. There are different type of vector databases which provide different type of features. Okay. You can increase top K. You can do chunk size optimization. A lot of things you can do. Okay.
Okay, well, okay, well.
Yeah, so I will suggest on paper, okay. Just look at this, just check now. Uh What was the name of the paper? Chunk size optimization. Archive. Okay, just check chunk size optimization on archive. So it says, okay, like what should be your chunk size for a given context window model? What is an optimal? I think chunk size utilization, something like that. Okay. So that paper is all about like for different LLMs given their context window, what is an optimal chunk size?
Found one rethinking chunk size for long document.
No, archive. It's an archive.
It's an archive.
Okay. I'll share. Wait, let me find out. It's here. Okay, we'll stop recording. I will take other questions offline.
Apart from this